Hello, we're back again. Um, we're going to start with looking at kind of a template example, and that is how should I think about the fraction 0 divided by 0? So this happens quite a bit when you're trying to take the limit. And so just to give you three different examples, suppose we're taking the limit as x approaches 0 of, let's say x over x squared versus the limit as x approaches 0 of x squared over x versus the limit as x approaches 0 of x squared over x squared. Okay, so in this first situation, if I try to just plug in 0, I get 0 divided by 0. In the second situation, I get 0 divided by 0. And in the third situation, I get 0 over 0. But algebra comes to the rescue, right? And so in this first example, instead of just trying to plug in 0 directly, we should cancel out that factor of x. And so this is equal to the limit as x approaches 0 of 1 over x. And so do we remember what happens in that situation? X equals 0 is a vertical asymptote for 1 over x, right? So as x goes to 0, this is going to blow up to infinity. And so the limit here, we could say, does not exist. Again, you could say it goes to plus or minus infinity. Plus infinity as you come in from the right, minus infinity as you come in from the left, if you want to be more specific. Okay, let's take a look at the second example now. In this example, if we do our algebra, we can cancel out one factor of x, and we just left with x. And now, what happens to this limit? Limit as x goes to 0 of x. Well, in this case, right, the function is just y equals x. Except, we do have to be careful. This is not the function, right? The original function, is not defined at the origin. Good, so this is actually a graph of our function. And here we see as x goes to 0, what happens to our limit, our y values? The y values go to 0. So here the limit is equal to 0. So this is a situation where we originally have 0 over 0, but then we concluded that the limit does not exist. Here the limit was 0 over 0, and here we concluded that the limit was 0. And finally, what happens in this situation? Here we have the limit as x approaches 0 is 0 over 0, but this actually simplifies to 1. And so this function is going to look like 1 everywhere except at 0. It's not defined, right? So in this case, the limit is 1. And so the upshot here is that if you have 0 divided by 0, is it possible to conclude anything about the limit? No, it's not possible. We have to do some more work. This was the work that we had to do. We had to do some algebra in these three cases. The limit may not exist at all. The limit may be 0. And notice in these two cases that the limit turned out to be two different numbers. So you can't say that, like, the limit of 0 over 0 is 0, right? Because here the limit was 1. You can't say that the limit of 0 over 0 was 1 because here we had 0. Okay, you get the idea. And finally, the limit may not exist at all. So if you run into the case where you have 0 divided by 0, we have to say, stop, we don't know what's going to happen. We have to do more work. We have to do more analysis. Maybe we can draw a picture, or maybe we can build a numerical table. Good. Okay, so now I want to take a quick look at some of the handout exercises. They are available on the class website. Let's see if we can answer a few of them together. So this first one, this is example 2 in the textbook. Here you have a g of x. Can you see everything that you need to there? So in this picture, if I'm trying to figure out what the limit is as x approaches 2 from the left, how would I do that? Well, here's the value 2. If I'm coming in from the left, that means I'm coming in from this side, right? And so if I do that, the corresponding y values are up here. And so the y values, it looks like, are approaching 3. So the answer for the first question is 3. I won't answer them all. I'll skip maybe to this one. So what is the limit as x approaches 5 from the right? So here's 5. I'm coming into 5 from the right, and if I look at my y values, they're up here, right? And so my y values, it looks like, are approaching 2. Good. And then what is the limit as x approaches 5 of g of x? Does the limit exist? Well, I'll give you a hint. The limit from both sides is going to be 5, so the limit does exist, and it's equal to 2. Okay, good. So now let's take a quick look at the next set of questions. These are a nice way of summarizing the intuitive reasoning for fractions. So if the numerator, the thing in the top, goes to 0, and the denominator goes to a constant that's not 0, what is your limit going to be? The limit is 0. Right? Again, that is if your numerator is going to 0 and your denominator is going to something that's not 0. Okay, then overall the fraction is going to go to 0. How about if the numerator goes to non-zero, numerator goes to non-zero, and the denominator does go to 0? What happens to your fraction overall then? Well, remember, in the denominator, it's getting very small, like 1/10, 1 over 100, 1 over 1,000, right? So 1 over that, or k over that, is going to blow up. So in this case, the fraction overall goes to plus or minus infinity. And that depends on whether your constant is positive or negative, right? And it depends on whether your denominator will be positive or negative. Good. What happens if your numerator and denominator both go to 0? We just looked at that case. No conclusion can be made. No conclusion. Do more work. And by that I mean we're going to have either, for now, we need either a table or a graph. And in 2.3, we're going to be doing algebra. How about the last case? What happens if the numerator goes to a constant and the denominator gets very big? The numerator goes to a constant and the denominator goes to infinity. What happens overall? Did you say 0? Because if you did, you're right. Good. Yeah, if the numerator goes to a constant and the denominator goes to infinity, then overall, then the fraction will go to 0. Good. And so let's do one more example here with this last problem. Sketch the example of the graph of a function f that satisfies all of the following conditions. The limit as x approaches 0 of f of x is equal to 1. Well, this means, let me scratch that, that the limit should be this number, right? If I want the limit to appear, that means that the function is behaving nicely close by. It doesn't have to be a line, but it's a curve just going into the point. I don't know what's happening outside of that point, but as x approaches 0, my y values are approaching 1. So that takes care of that guy. F of 0 is minus 1. And so I would put the solid dot down here, and that takes care of that guy. F of 3 is equal to 1. 1, 2, 3, 1. That takes care of that guy. X approaches 3 of f of x is equal to 2. What would that mean? Oops, I'm running out of space here. At 2, this is 3, and as x approaches 3 from the right, my y values are going to 2. Something like that, maybe. And then over here, so that takes care of that guy. And so the limit as x approaches 3 from the left of f of x is minus 2. So minus 2 is down here. And so, oops, I don't want a solid dot there. I want an open dot at negative 2. And so I want to have my limit be that. So we could say that the function is coming down like that. And that takes care of that guy. Okay, so now we've got all our requirements. One requirement, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. And now we should connect the dots somehow. So I might draw my graph nicely like that. Draw a nice graph. A nice picture. A nice picture. Very good. And so here we have our solid dot. Beautiful. Isn't that a thing of beauty? Very good. Okay, I think I've spent enough time in section 2.2. If you have questions about the homework, either send me an email or set up a meeting. We can chat. Okay, see you later.